What is up, and welcome back, Math 1. I believe this is the first video of the semester. Um, the first video that I'm going to be making is about the skills quiz, the second skills quiz that we've had, and go over the solutions just so that way you can refer back to them and see if you need to improve on anything. Um, Future videos this week as well as next week will include more of the problem solving process, a little bit of notes and stuff like that. But I figured this would be a good video to start off this semester so that way we can kind of get a good overview of where we need to be. And then you can find the video notes accordingly to understand the different pieces of this quiz. So without further ado, let's get started. This quiz is all about solving for a missing length. So you'll see in all of these problems in orange, there's a value that we need to solve for in order for us to answer certain questions. And so while we go through this problem solving process, we're going to need to actually determine the best way of finding those solutions. So for number one, let me go ahead and zoom into this. We want to set up a pair of equivalent ratios. Okay, equivalent ratios, we'll talk about in just a second of what that means, to solve for the missing length. Write an equation is essentially what we're doing. Okay, you do not need to solve for it. Awesome. Well, in a problem like this, when you have two shapes, the thing that I did as a teacher inappropriately that I should have made sure to clarify, and I did in class, is that these two shapes are similar. Okay, it's really important that I make this distinction, especially when you don't have other values to associate to confirm or deny that these shapes are in fact similar, but they are similar shapes. And so for this, we need to find something called corresponding sides. Okay, so if we identify some corresponding, in other words, matching sides, then we're able to start this whole process of making equivalent ratios. So in green, the first pair of corresponding sides is going to be this 5 and this 13. Okay, they're corresponding, they're matching, they're on the same side of their respective triangles. Similarly, we have a 2 and an x also considered corresponding. And so there's a couple different ways that we can set this up, and I'm going to use colors to illustrate this now that we've identified corresponding sides. The first way we can set up some ratios, and actually let me do this off to the side here. Okay. So the first way we could set up some ratios is by setting up fractions using those different colors. So we have our green values, and we set those equal to the blue values. Okay, so your fractions or your ratios and your equation would look something like this if we were to just use colors. Okay, another way you can do this is just by using ratios within each triangle. So this is looking at between the shapes, right? So we have one shape here, the second shape here, one shape here, the second shape here. So we have first shape, second shape, second shape, second shape. Okay, so this is between. We're looking between the two shapes. Okay, or we can look at within each shape and have different ratios using the colors within those actual triangles. So here, if I just used colors, it would look something like this. Okay, where we have greens on top, and this is for shape 1, shape 1, shape 2, shape 2. Okay, so to make this a little bit easier, I'm going to go ahead. I'm going to just erase some of these arrows and lines so that way we can see what we're going on. But just using colors and visualizing how to set up some of these ratios, there's a couple different ways to do it. So this is a between ratio. This is a within ratio. Another set of within ratios is if we just take these colors and just flip them. So now the greens are on the bottom, and then we have blue on the top. Equals. Okay, and so it just depends on which numbers you want to put. So if we're looking at between ratios, maybe I use the 5 for one of the shapes and 13 of the other. Those are both green, and then a 2 and an X. Okay, And then if we go within, I can do a 5 over 2, both in the small triangle, and then 13 over x. Remember, so the greens are going to stay green, but I'm using it within the same shape. Or I could just flip them. So for this specific problem, I'll take any of these four answers, or any of these three answers, I'm sorry, as a solution, and you can articulate your equivalent ratios in this way. Okay, we'll talk more about this. There's a few students who need some extra work on this stuff. We'll talk more about this as we continue in class. But there's three different ways that you could have set this up, and I hope the colors are there to help you visualize a little bit about what we're looking at. So that's number one. Those are the equations that you can use to solve for the missing link. Okay. Number two. Now, for some reason, number two had a lot of questions because students saw the decimal values and immediately said to themselves, Hernandez, I don't know what to do. I'm stuck. Decimals have values, and I guess decimals are valuable, right? A lot of things in the world, especially like bank accounts, for example, use decimal values to help illustrate something. And so we got to learn how to use them and be comfortable with them. Um, and for that, let's see what we can do. So the first thing we got to do for any problem like this, I'm going to do it in orange, is we need to find corresponding or matching sides. Okay. Once again, I did the teacher mistake. These are similar. Okay. Or I guess I write that they're similar, but I needed you to prove to me, are they actually similar? And this is something we're going to be transitioning to into next week. How do we actually voice this and make sure that we are sure that they are in fact similar? With this, they're going to be the same orientation, which is great, but the way to prove that they're similar is that the sides need to be actually proportional. And so we'll talk more about that a little bit this week, and we'll keep talking about it maybe a little bit right now. Okay, so let's first find the corresponding matching sides. So 1.2, 14.4, those would be considered matching. We have 2.5 and 30 matching. We have 12 and the question mark over here. Those are matching. And then finally, we have 1.4 and 16.8. Those are matching. Okay, so I'm using these colors to illustrate the corresponding sides. Now, if we want to say that things are similar, we need to make sure that these corresponding sides are proportional, which means that all have the same ratio. All pairs, I should say, all pairs have the same ratio between them. And so we need to do some math to kind of prove for this, and then we need to hopefully solve for whatever this missing value is. Okay, so let's test it out. And let's actually just test this out and find the missing value using any combination. So the first issue that I see with students is you think you have to use all the numbers, right? There's 7 numbers and 1 question mark. Not necessarily. Okay. So similar to number 1, let's set up a ratio using those orange corresponding sides. Now, we want to use orange because that is one of the ratios that includes the question mark value, the value we don't know from the smaller image, and the 12.0 from the larger image. Okay, in order to solve for the missing value, we need to have something to solve for. Okay, so for this case, I'm just going to go ahead and instead of a question mark, I'm just going to call it X. Okay, I'm just going to call it X. And you can do the same thing whenever you get to a test or quiz. I'm going to call it X because I want to solve for it. So for here, question mark turns into X. Now, the second fraction that you can choose, or the second set of corresponding sides that we can solve for, we would like to use any of the other combinations. So we can use pink if we want and represent a ratio like that. Or if we really wanted to, let me go ahead and come down here. If I were to rewrite this over and over and over again, we can use any combination of corresponding sides to help us solve for the missing side length. And it doesn't matter which ones we use because we're testing whether or not our proportions are all going to be the same, which means we should get the same value for x for all of these solutions, no matter which combination we use. So I can use the pink ratios, I can use the green ratios, or I can use the blue ratios. Now, the reason why I use colors is because it helps to visualize which values I'm talking about, but it doesn't matter which ones I use. Now, what you can't do, or what we shouldn't do, is set everything equal to each other and have a chained equation, right? That's not helpful because we have things equal to things, equal to more things, equal to more things. That will get us more confused. So the equations that I want us to deal with are going to be using only one equal sign. You should not set everything together. So for all of these values, you could take your pick and solve any single one of them just to see what you get. Okay. So for the sake of this problem, let's go ahead with this first one with the pink ratio with 1.4 and 16.8, and let's see what we get. In class, there's a lot of different ways that we've explored how to solve a problem like this. Okay. The first method, or I guess the foolproof method of solving, is just simply cross multiplying. And if you recall, when we cross multiply, we are actually multiplying the denominator on one side with the numerator on the opposite side. And when we do this, you allow ourselves to effectively not necessarily remove the fraction, but make it easier, or I guess simpler for us to solve without it being in this form of a fraction. And so here I went ahead, and if you notice, I multiplied the denominator of one side with the numerator of the other, and we get a combination that looks like this. Okay. And we're multiplying, effectively, we're multiplying. And then we can simplify this to 16.8x equals, and if you take a calculator, there's always going to be a calculator on your task list. We will end up with 12.0 times 1.4 is going to be 16.8. And this starting to look interesting. To get the x by itself, remember we want x to be by itself at the very end. We need to split up this 16.8 and this x value. To split up a value of multiplication or a product, we're going to need to divide that value by everything within the problem, especially the things on the other side. So 16.8 and 16.8, those reduce down to a 1. And then that means that this also reduces down to a 1. It's not 0, which means x equals 1. Well, that's interesting. That is interesting. So if I were to use this value and I were to go back and either plug it in, or if I were to just simplify all of these values, I would end up with the same exact value of 1 for this x. Okay, and because all of them would be equal to 1, we can say that these two shapes are effectively similar. Okay, that's one way that you can solve for it. Okay, another way that you can solve for it, I'm going to use the this green ratio here. So if I come over here and I go ahead and I rewrite it, let me show you another way of doing this. And I believe there's some students in our class who have shared this method, and I really like the way you think about it. Boop, 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 boop. And I go ahead and I make another set of another equation, but this time using the green ratio, 2.5 and 30. What some students did here is they took the initiative and they just went ahead and they flipped it. They took the reciprocal of it. They flipped this relationship to make it a little bit easier to solve. Now, why is it easier? Because the larger values are now on the numerator or in the numerator position. And this makes the math a little bit not necessarily simpler, but maybe more straightforward to answer. And so if you were to do this, some students, instead of cross multiplying, you actually simplified this little piece of the puzzle or this fraction, which means you take 30 and you divide it by 2.5. And if you actually did that, then you end up with 12.0 over x equals, this also equals 12.0. And so if you were to read this problem and think to yourself, what does x need to be in order to equal 12, in order for both sides to be equal, then you would see that the only thing that would make sense is that if this x equaled a 1, because 12 divided by 1 is 12. So you can come down here and effectively also say that x equals 1. Now, if you were to check this problem and then cross multiplied, you would still end up with x equals 1. There's a couple different ways that you can go to this. So here's two different methods that I've seen some students do to get to this answer. And either way you do it, it's going to equal the same thing because these two shapes are, in fact, similar. Okay. So now number 3, I'm going to come over here off to the side, give myself a little bit of extra room because this problem gave some students a hard time. And we need to talk a little bit more about this type of stuff, especially this next week, okay? So the first thing I want to do with any one of these problems, especially when I'm solving for a missing length, is I want to find some corresponding sides. But that's hard to do, especially when you have an image like this, because a lot of students don't see two triangles or two shapes. So for this, I'm going to go ahead, I'm going to use another color. I'm going to use a darker pink here. And if I go ahead and I outline the biggest triangle. So if you were to just look at this from a glance, you'd probably say to yourself, oh, Hernandez, that's a triangle. That I could see the triangle, right? That makes sense. And so for this problem, I'm going to go ahead, I'm going to take this pink, and I'm going to see if I can redraw this triangle for us to use. Boop, boop, boop. Beautiful. Okay, so I'm just going to draw it. I'm not going to label it or anything yet. I'm just going to draw it. Okay, the second triangle, I'm going to use, let's use yellow. I'm going to come in here. The second triangle is actually located on the top half of the first triangle. So if you take a look, there's actually two triangles here. They are overlapping each other to create another image. And so here, if I go ahead and I take yellow, let's see if I can make this a little bit more vibrant. If I take this yellow and I come over here, I effectively have a second triangle to play with. Okay, so there's two shapes in this image. They're both overlapping. So the yellow is actually on top of this pink triangle, except to make this image. So if you can see that, then that's the first step in your problem solving process. Okay. The next step is being able to label effectively the sides of each triangle. Now, I like using the smaller triangle first because that makes it a little bit easier for me to actually visualize what I'm going through. And so for this yellow triangle, we can see that there's the right side length is a value of 5, and the bottom is x plus 2. And then for the larger triangle, the bottom is a value of 15. Uh-oh, there's a problem. Because according to this image, this bottom half of the triangle has a value of 7. But then the top half of this triangle has a value of 5. Now, because there's no indicator that shows you an entire side length to distinguish the two, we have to assume that each of those sections effectively is that length, which means for me to find the total length of this side of the triangle, this entire thing, I need to take those two values and solve for them by adding, or I guess add them together to solve for that side, which gives me a total value of 12. So now if I go ahead and I find my corresponding sides like I've been doing before, I would get a value of 12 corresponds to the right side of the small triangle, and then 15 corresponds to the x plus 2, or the piece that I don't know in the other triangle. Okay. So starting this type of problem is probably the hardest part, and that's what hopefully you're going to start learning how to do and apply as we move forward. Okay. So once we do that, we can set up equivalent proportional relationships because these two images are going to be similar. They are similar triangles. And we can do that a couple different ways, like we said before. So you can either have the blue ratios equal to the green ratios. That's an okay thing to do. Or you can flip them, move them around. You can have the greens on top, blues on the bottom. Okay. But what it should never look like is a checkerboard. Or here you can have the blues on top and then the greens on the bottom. Okay. So a lot of students, when you see the colors, this kind of helps out a little bit because you can see how you could set up those ratios. You just kind of plug it in like a puzzle. But what it should never look like is having green on one side and then green on the other. Okay. Part of the reason is when you go to simplify this, uh, it's going to end up with greens being multiplied together and blues being multiplied together. If you take a look up here, we want to mix and match those, right? We want blues and greens to be crossing over. We want to be able to find the relationship using both of these shapes, and we want to make sure that we're not just multiplying two of those things together, right? That doesn't help us solve for some of this problem or for these problems. Okay, so I'm gonna just plug in some of these values: x plus 2 and 15. I'm gonna go from the bigger triangle to the small triangle here. 5, so I have 12, 5, 15, x plus 2, 15, x plus 2, 12, and 5. You can solve using any of these methods, and they should all give you the same answers. For this specific problem, however, what I'm going to do is I'm actually going to use the middle value and see if I can use this to solve for the problem. So however you feel comfortable, you can solve for. Okay. So I'm going to do 12 equals 5, 12 over 15, that is, over x plus 2. And the first thing I'm going to do is go ahead and cross multiply, so that way I can help simplify my problem solving and get it to be more manageable. So I get 12 times x plus 2, and you always are going to put whatever value you're bringing up from the denominator into a set of parentheses. Always. And this is the reason, because sometimes you have, this is called a binomial expression, where you have two terms, and you always want to make sure that you keep that as two terms because it's not one number, it's actually two. And so we need to do something with that in order to help us solve. Okay. So here, if I go ahead and I simplify, the right side's pretty easy. It's 15 times 5. If you go ahead and plug that into your calculator, you should get a value of 75. And then the left side here, we're actually going to do something specific with this 12. Because we're multiplying, we have to multiply this 12 with everything in the set of parentheses, and this process is known as distribution. I'm going to distribute the 12 to the x, and I'm going to distribute the 12 to the 2. So I end up with 12 times x plus 12 times 2. Okay, this is something that we've been referring back to, and some students are starting to forget this process from the middle school days, but that's okay. So you want to make sure that you start understanding when you have a set of parentheses with two terms inside of it, you have to multiply everything directly adjacent to those terms with everything on the inside. Okay. Continuing, we get 12x. We can't simplify that anymore. Plus 12 times 2 is a value of 24. Okay. Now, remember, we want to solve for x here. Okay, x. I want x by itself. I want x to equal something. But in order to get to that point, I need to get this by itself. Right? I need to get the term with the x by itself. So in order to start that process, I need to subtract a positive 24 from this. I need to get rid of that. Boop, boop, boop. In order for us to continue. So 24 minus 24, that's 0. That's going away. Okay, and I can bring down this 12x. And then I can set that equal to 75 minus 24. I get a value of 51. Get a value of 51. And then I can go ahead and simplify this problem. I get 12x equals 51. And then I can divide that 12 like we did in a previous problem, split it up, and I end up with x equals 51 divided by 12 is a value of 4.25. Great. So in this problem for number 3, I actually asked you solve for the missing length. The missing length, not the missing value. So we need to take this number and come back in and realize that the missing length of this side, we don't know because we don't know what x is. But now that we know what x is, the missing length is going to be this x plus 2. But the x we know now is 4.25 plus 2, which means 4.25 plus 2 is a value of 6.25. So this whole length here is a value of 6.25. Okay. So with that said, watch through this video again. See if you can pick out something that you can learn from it. See if you can make some corrections or some adjustments on your skills quiz. And with that, we will come back and hit the ground running when we come back to school. But for that, we are done for this video. Hope you enjoyed it. Hope you learned something. And I will see you next time.